All right, so if you're seeing my screen, it says to identify the area of circle K in terms of pi. So they're just referring to the center of the circle. The area of a circle is pi r squared. You probably saw this in a previous class. What is the radius in this problem?
7.
7. So what is the area?
The area is pi, 49.
49 pi, which so generally put the pi after, and then the centimeters, is it centimeters squared, centimeters cubed? What is it?
I think it's centimeters squared.
Because it's an area.
Yeah.
All right, excellent. Okay, so this formula you got to know. Remember we did a formula last time for rhombus and kites and parallelograms. This is just another one of those formulas you got to know here. So here's a really similar problem. I'm gonna snip this in. This time though, they don't give you the radius. Do you remember what it's called when you go all the way across in a circle?
Circumference.
Circumference is actually going all the way around. This is going across.
Oh, that's the diameter. Sorry. I thought you were, when you said all the way around, I was thinking of the circumference.
Okay, so how are the radius and the diameter related? Do you remember?
So they're related because the radius is only half the diameter.
Right, or the radius is 1/2 the diameter. Very good. So in this case, what is the radius?
The radius here is 8.
And what are the units that go along with it?
Pi square.
Units. Units means units of measure.
Centimeters.
Like centimeters, perfect. Okay, so the area of a circle is pi r squared. What is the radius?
Radius is 8 squared, so that's 64 pi centimeters squared.
Perfect. Okay, that's great. Yeah, I mean it's once you do one, you're like, oh, I get it. Okay, so here is another problem to do. And this time they don't give you a circle, but they tell you it's a circle. Let me snip it in, you'll see what I mean.
Okay.
Okay, so an artist is drawing 3 large circles on the ground with diameters of 6, 10, and 13. Okay, so what are their radiuses? So
the radius of 6 is 3, and then 5, 6.5.
Perfect. So you need to find the area of each circle. So it's pi r squared. Okay, but this time they want you to round to the nearest 1/10 of a meter.
Okay.
So for this first one, it's pi 3 squared, which is 9 pi. Do you have a calculator with a pi button on it?
Unfortunately, no.
Okay, so let's use that Desmos Scientific.
Okay.
Let me chat it to you so you got it. So for each one, you have to do this calculation, right? Like that's just for the first one. Then you got to do it for the second one, then for the third one. So I'm looking for the 3 areas, but you got to round it to 1 decimal place.
So I put in 9.
So tell me what you get for 9 pi.
28.27.
Now it says nearest 10th. So how many decimal places is that?
That's only 1 decimal place.
Okay, so is it 0.2 or 0.3?
0.3.
Very good. Okay, and the units here would be meters squared. So give me the next 2, right? You got to do it for 5 and then for 6.5.
Yeah. 15.7. For 5.
For which one?
For number 5.
What is the formula for area?
Oh, sorry. I am sorry. Let me give you the correct one. So that is 78.5
meters squared. So see if you can do the last one completely correct, please.
20.4 meters squared. No.
It's not a race, right? You gotta do this correctly.
$132.7 meters squared.
Perfect. Now you did that so well Guess what you get to do?
I don't know what I get to do.
You get to do one in the next problem, which is exactly the same, except it's different numbers.
I wouldn't really call that a surprise. I'd probably call that a
So again, they give you the diameter. Do you need the diameter?
no
You need the
radius.
So give me the radius of each one.
So for the first one, I get 50.
No, what's the radius?
Oh, the radius for 8 is 4, 6 for 12, and 7.5 for 15.
Okay,
So
give me the first.
The first one is 50.3.
Okay, and what's the next one?
So next one is 133.1.
I don't think that's correct. It's 113.1.
Sorry, 13.1.
Okay, and the last one?
And last one is 176.7.
Perfect. Okay, we're going to move on to the next style of question. This one is a pretty good question. There's a lot of things that are going on here. So it says identify the circumference of circle S, okay, with this area. So the formula for circumference is 2 pi r. So notice you need the radius.
Mhm.
Do you see that?
Yes.
You're given the area. The area is, what's the formula for area?
Is pi r squared.
So they're telling you the area is 64 pi equals pi r squared. So notice if you divide by pi,
Mhm.
what does r have to equal?
R has to equal 64.
R squared is 64.
Oh, r squared 64.
So what is r?
R is 8.
8. Okay. And why did we need r? What were we trying to find?
The circumference.
And the circumference is 2 pi times 8. So what's the circumference in terms of pi? You don't have to round this one.
So
like there's a number and then pi. That's what I'm asking you to find.
Oh, okay. So 16 pi.
Perfect. Okay, so you did that so well that guess what you get to do?
Yeah, I get where this is going.
Actually, this one isn't exactly the same. You have to find the diameter.
Oh,
so first find the radius.
So what is my radius?
Well, it's not given. You have to use this equation.
Ah,
So I want you to solve for r.
can you go back up to that other equation there?
Well, what is keeping r from being by itself?
Well, it's the
what is this
pi.
pi? The pi needs to be divided because it's multiplying.
Yes.
Okay, so 169 equals
The
what's
ones
left over?
are radius squared.
Okay, so how do you undo a square?
So you square root both sides, which is, so I shall give you the answer.
This is
13.
one you should know. You should know the square root of 169 is 13. Like that's one that you want to like really know. Now we don't want the radius, we want the diameter. So what is the diameter?
So diameter, that's 26.
26. Perfect. Okay, very good. So we're gonna move on to another thing here. Excuse me. All right, so this will be the Thursday lesson. It says it's a continuation of what we just did. So hopefully it's just more of the same types of stuff. Nope, it is not. All right, it looks like it's pretty different. Okay. Do you remember looking up in do you remember in your notes if they gave you a formula for a regular polygon?
I think so.
Okay, so I'm gonna look as well, but that's where we're gonna start with. Area of a regular polygon. All right. Well, it's a bit of a okay. So there is a known formula which I didn't know if this is what they give you. The area of a polygon is always 1/2 the apothem times the perimeter. Do you remember seeing that?
Yeah.
Are you sure? Because it's a little bit um, odd.
I have seen that equation, but I've had a hard time using that.
Sure. So like the way you would use it is, and we'll look at it for the first problem here. Let's actually use a hexagon as an example here. Because we can draw this and we can so it says identify the area of a regular hexagon. So hexagon has 6 sides
Mhm.
like this. It says each side length is 25. Okay. Now we kind of we're kind of cutting through some of the math here, but it ends up that the interior angle of this right here
Mhm.
is this. It's the sum of this, which is n minus 2 times 180.
Mhm.
Okay, so there's 6 sides. 6 minus 2 times 180, which is 4 times 180, which is 720. But then you divide it by the number of sides, which is 6.
Mhm.
So that equals 120. So each of these is 120,
Yeah.
but then you cut it in half again, and that makes 60.
Yes.
Okay, so a lot of work to get that there. Now, the let me just draw the hexagon again. The apothem is the distance from the center to here. See how it meets at a 90-degree angle? So it would be
Yes.
like that right there. That's not given. That is what you have to find.
Oh.
Okay, and it requires you to use some right angle trigonometry. So for example, let's say you had this angle right here.
Mhm.
Okay, and you knew that this whole side length was x. So that means that this right here is x over 2. So your triangle there, here's what you have in your triangle. You have theta and x over 2. And we really want what's called the apothem. So the tangent of theta equals opposite over adjacent, right?
Yes.
Okay. So to undo this is a little bit weird, but you multiply both sides by x over 2.
Mhm.
So the apothem is always x over 2 tangent of theta. Okay. Now the angle, we just calculated the angle. The way you get the angle is you take the number of sides,
Mhm.
okay, times 180 divided by n, but then you cut it in half again. That looks really complicated, doesn't it? Doesn't that?
Yeah, I'm trying to just trying to all memorize this all and trying to write it down all at the same time.
It's a lot.
Yeah.
Okay. Okay. So there's a shortcut here. So the shortcut is that the apothem is, and I guess I'm okay with you doing it this way. It's the side length over 2 times the tangent of 180 over n.
Mhm.
Okay. So the area of your polygon for all of these is going to be 1/2 the perimeter times the apothem. And the apothem is this formula right here. And the area of the polygon is this formula right here.
Okay.
So you want to get both of these down for the moment. Then we'll go back and do a problem because they're all going to be the same.
All right. Okay, got him.
Okay, so let's go back and do the first question here because they're all going to then be calculator problems after we do this. So, oops. Okay, so it says identify the area of a regular pentagon with side length 11. So pentagon has how many sides?
Has 5.
5 sides. So the perimeter here is 5 times 11.
That's 55.
55, great. The apothem is that formula we just mentioned. It's S over 2 times tangent 180 over n. So S in this case is 11 over 2 tangent 180 over 5.
I see.
Okay. Now I'm gonna so in your Desmos, here's what you want to do. You want to have a 1/2 parentheses. Okay. And you actually want to do 5 times 11. Because remember, it'll do that for you. And then another parentheses, you want to have 11 over 2 tangent 180 over 5. And I'll show you why in a moment here. This is the power of using this calculator. Because the next problem, we're going to change this number, this number, this number, and that number, and nothing else. Right. So it's a lot there. I'm going to enter it on mine as well. And we're going to compare results here. Again, and use the parentheses the way I showed you. That it will really help if you do that.
Yeah, I am. I'm just doing that. Okay, I think I have it.
What's your answer?
208.1777655.
What does it say to round to?
Then to the nearest tenth, so that would 0.2
Perfect. Okay. Now it is an area, so that's centimeters
squared.
Perfect. Okay. So now the power, like that was a lot of work to do for one problem, right?
It is.
Okay. So for the next problem, do you see the reds?
Yes.
See the red lines? Okay. So like this is n, the number of sides.
Yes.
S, and n. So in the next problem here, you're just going to change those numbers based on what we have here. So let me snip this in. Okay, you don't want to delete it all. So your hexagon is n equals 6 sides, and S is now 25.
Okay, I get 1,623.8.
Perfect. Okay. All right. Now, the next one, it's the same thing. Okay. But now it's a nonagon. How many sides is a nonagon? And if you don't know, go out and
9.
Go out and look on the internet and just double check. See if, because this is well-known information.
9 sides.
So n equals 9 and S equals 18. Perfect.
2002.9.
What are the units?
Oh, centimeters squared.
Perfect. Okay, couple more here, but guess what they are? They're all the
They're the
same.
same thing. Thank
Yep.
God.
Well, thank goodness you got the right formula here. So a decagon has how many sides?
10.
And S is now 5. So go ahead and update that and let me know your final answer, please, on that.
$192.3. It says it has their 0.35. So would it be 0.4?
5 rounds up to the next one.
Okay, so 0.4.
Okay. So now here's the next one. N equals 10 and S equals 2.
Okay, I get 30.8.
See here. Yep. And then the last one here is a octagon. Octagons are stop signs. How many sides does a stop sign have? You're driving now, so you maybe know
6.
this. Nope. Hexagon is 6. Octagon.
I'm thinking, yeah, sorry. Octagon is 8.
Okay. And S equals 6. So give that a calculation for us, please.
$173.8.
Perfect. Now, this formula is going to come, these questions are going to come back up again on your quiz and on your test. So definitely write it down and make sure you've got it handy so that when that comes, when that time comes, you can just look it up real quick.
Yeah.
All right. Well, that takes us to the end of our lesson today. Thanks so much for scheduling, and I'll see you next time.
All right. Thank you.
Okay, bye now.
Bye.